5 questions. There were only 2 more, and those were the attributable risk. Let's see, we're going to need this rate in the total. Let me write it up here. Rate in the total was 0.20. All right, so question number 6 then was to calculate the attributable proportion among the exposed. We abbreviate that capital A, capital P, small subset or subscript E for exposed. And the formula is simply the risk difference that we already calculated, rate in the exposed minus the rate in the unexposed. That's the RD that we calculated already above. But in this case now we divide by the rate in the exposed and take it times 100 so that it becomes a percent. So we had the 0.315 minus the 0.112 divided by the 0.315. So we'll have to do that calculation first. So there was that risk difference of 0.2 and then it's divided by the 0.315. So we get a 0.6444. So we're going to convert that into the percent, right? Moves the decimal point 2 places, 64.4%. So that is the attributable proportion, right? A proportion is usually expressed as a percent. So 64.4%, and then the sentence would be, of the cases among the exposed, among the tomato eaters, would have been attributed to, or you could say, what is this word? Among the exposed, could have been avoided by not eating the tomatoes, not being exposed. Okay, so among the exposed, 64.4, that's almost 2/3 of the cases could be attributed to the tomatoes. The rest of the cases were some other food that was also must have been contaminated. Okay, so sometimes we're asking attributable proportion among the exposed, but sometimes we're asking the attributable proportion among the total population. So the whole thing is very similar, except now we use the rate in the total population. So that would be attributable proportion, and now you have a subscript T here, total population, and then you have the rate in the total population in those 2 places. And then instead of the 0.315, we have the 0.2. Okay, so now we can do that calculation, which is 0.2 minus 0.112, and it gave me an error. What did I do wrong? I put too many minus signs. 0.2 minus 0.112 is 0.088, and then I divide by the 0.2, and I get 0.44, so that means 44%. That's the attributable proportion among the total population. So 44% of the cases among the total population could have been avoided by having all those people not eat tomatoes. Okay, so just like the population risk difference is a smaller number of cases per 100 than when you just look at the exposed, the attributable proportion among the total population is going to be a smaller percent than the attributable proportion in the exposed group, because the exposed group were all exposed. There's more possibility of them getting the salmonella from that exposure, and so the percent that's attributable to that cause in the exposed is a higher percentage. So sometimes you also want to know, well, if we did a campaign to prevent that exposure, what percent of the total cases could we avoid? And that would be that number. So that's how to do the more tricky calculations in Chapter 3. So you can rewind this and play it as many times as you want, and hopefully help prepare for Monday's exam.